Jar Jar was an actual thing.
It's not Darth Jar Jar. It's Jar Jar as Darth Plagueis. So all the evidence is interesting, but that's just what do you call it? When it's not strong evidence, circumstantial. It's all circumstantial, except the audio recording of George Lucas from the original, not from the Phantom Menace behind the scenes, where he was saying Jar Jar is the thing that's going to tie this all together. But they changed the script because there was so much backlash after Phantom Menace saying Jar Jar was terrible that they wrote it out.
If you watch what he keeps saying after that, he's like, well, he's the funniest character that we've ever done. He's the key to all of this. Like, I think he just meant he's the key emotionally to, like, make the movie work.
True.
Right? And I think what they were probably seeing in screen is, this character is stupid. It's not going to work. And he's like, this has to work. He's the key to this whole movie. And
it is all circumstantial.
I don't think he meant like the key to like the entire universe.
Hey everyone, we're live, by the way. This is Star Wars Weekly podcast.
No, it's not. So let's do introductions. Welcome back to another Batobi training. With me, as almost always, is Alexis Brill. Hello, Alexis. And I'm really excited this week because I am not doing the majority of the training, or really any of it this week. I just get to sit back and watch Matthew here. Hey, Matthew.
Hello.
He is going to talk about some how to make server-side rendering work. Are you going to touch on the new stuff that you just did?
I think so.
Oh,
yeah.
Very exciting. So people know that like isomorphic, might have heard the term isomorphic JavaScript or universal JavaScript. Or what we like to say is server-side rendered JavaScript, because, or like a server-side rendered single-page application. What it really means is, can you use the same code on the client and on the server? Now, a lot of other frameworks, they let you kind of do this. Like React, you can render a template to a string. Well, that's something that, you know, you could do in the earliest version of CanJS. Of course, Node didn't exist then, but wouldn't have been hard to do. What hopefully Matthew will show is that we think that our server-side rendering solution is pretty unique in how easy it is to port an application that you would normally just write to work as a single-page application, and then suddenly it just works pretty much with very little extra effort to be server-side rendered. And the reasons why people do server-side rendering are because it's nice to send a page where the user can see what's going on, and that they can see a response with the content of the page right away, and their brain can start thinking about their next action. The page feels much faster. And there's so much research that shows that the faster a site loads, especially from a user's perspective, the more people are happier, they're more likely to buy products, conversion rates go up, that kind of good thing. So it's an awesome topic, a very important topic right now. I'm excited to see what Matthew has to say about it.
Sure. I think you went over like half my slides, so thanks. That's okay. That's all right. Okay, let me share my screen here. So you're going to see I'm doing a talk on this next week at Node.js Interactive, a conference in Portland, Oregon. These are very early version of those slides, so I'm going to polish these up, so forgive me for that. But yeah, I'll go over the slides, and then I think maybe we'll look at some examples, a couple of examples of how to use this, and kind of how Done.js's version of server-side rendering makes things particularly easy. So, all right, let's go back. Actually, go back. Okay. So yeah, my name's Matthew Phillips. Talking about our server-side rendering implementation in Done.js. Have we talked about Done.js on this before? I mean, I know we've talked about CanJS and Steel, but have we talked about the umbrella project?
I think so.
I don't think we have actually.
No? Okay, well, let's do that real quick. Dun.js, you go to dunjs.com. This is our full stack JavaScript framework. It includes CanJS, which I know we've talked about. It includes Steel.js. Where's the one that shows all the different projects?
Guys has all the different projects.
Guides does?
API.
Oh, APIs. Yeah, you're right. Okay. Yeah, so it includes all this different stuff: testing, module loading. We do deploying. We do documentation. We do just about everything. This is what Dun.js does. Part of that is Can SSR, and Can SSR is our server-side rendering for Dun.js. Now, if you don't know what server-side rendering is, that's okay. We'll go over that. Here's some key terms that we talk about often when we talk about server-side rendering. Justin's went over a couple of those. We talk about having a shared code base, that is a code base that runs on the server and also runs in the client. Isomorphic is a term that's used. It kind of means the same thing. Universal is a more recent one I've been seeing people say. You could also say that you want to keep your code portable so they can run in different environments. So why bother with server-side rendering at all? Like why even worry about it? To be honest, like in a lot of cases, it doesn't matter as much. But if you're working on like applications that run like within your company, it might not be as important. It depends on what you're doing. But definitely, I think any outside-facing project, anything that's on the open web, it's much better to have it be server-side rendered. So there's a couple issues. There's obviously the fact that in a lot of places, even in the U.S., people don't have great connections to the internet necessarily. The faster you can have something shown to the user, it's been shown, the more likely they are to use your application, to buy stuff from you, or whatever it is that they do. So yeah, perceived performance is a huge thing. No one likes seeing a spinner when they go to your web page. SEO matters as well. Google is able to execute JavaScript nowadays, so maybe it's less of a problem with Google, but no one really knows to the extent to which they do this, the extent to which they can capture applications without server-side rendering, and no one knows if other search engines like Bing or Yandex do this. So there's definitely some benefits. SEO, if you want to definitely get good at SEO, having server-side rendering is pretty important. All right, I'll go over a brief history of doing this kind of thing. This is not necessarily just server-side rendering, but talking more broadly about sharing code between the client and the server. Kind of the first thing when Node first started coming out was just simply sharing templates. EJS were like kind of the earliest templates. The Express framework, I think at the beginning Express defaulted to EJS, so a lot of people were already using EJS in the client anyways. So you could easily just have the same templates and use them in the server and the client. But doing this, there's still the problem of all the logic of your application is not just a template. It's separated out. So having that shared between the client and the server wasn't really solved at this time. Another thing people did later, and we did this ourselves, we had a project that tried to replicate this, is using a headless browser. The headless browser is a browser that runs on the server. It's called headless because it doesn't actually open a visual part. It just kind of runs on the server. Phantom.js is the most popular, I guess. JS DOM is a version that runs within Node. But what they do is it opens an actual browser that can do anything a browser can do. So there's some advantages to this, right? There's also some disadvantages. It consumes a lot of memory because each time you open a web page, you have to open a new instance of the browser, and because of this, you usually need to have some type of pooling mechanism. You might have a lot of users hitting your site at the same time, so to service all of them, you need to open a different tab in the browser for each user. so you need to create polling somehow, so it's like scaling becomes more difficult. The advantage is that this tends to be like really fast because these headless, well, particularly Phantom.js is based off WebKit, and it's as fast as WebKit is. Actually faster because it doesn't need to paint to the screen. Another problem would be that it needs to be continuously updated. These are open source projects. Anytime any new JavaScript feature lands, they need to update their JavaScript engine. This is a hard thing to do, hard thing to keep up with the standards, particularly because these are not full-time jobs, the people working on these projects. So a lot of people did this. It worked well for a while. It doesn't scale particularly well. More recently, there's been these virtual DOM projects, not just virtual DOM projects, but I think more frameworks in general have made an effort to make their code universal so that it can run in the server as well as in the client. So the advantage is that you actually are running the exact same code on the client and the server. Well, most of the same code, I should say. There's always been certain parts that differ, and that's kind of one of the big benefits of Done.js is it reduces those parts to very little, the very absolute minimal amount. So the advantage of this is it runs within a single node context. That means it doesn't launch new instances of node for each user. There's just one instance, which is nice. It's stateless, so basically we're just running a function and getting the result of a function. There's no state kept within the app. Rendering is synchronous, which is a bit of a disadvantage. In any application, you're going to break things up into components, and components do things like make requests to get their own data. And this becomes very difficult to do with these virtual DOM libraries because they just render. Yep.
When you say stateless, like, are you saying that other things are stateful? Like, what are you comparing that to?
Well, I'm comparing it to the headless browser approach, where you like run the application. It contains a state. If you want to render a different page, you have to change the state in order to get the different page, or you have to tear down the browser and launch a new instance of it. But in this approach, it's stateless. You're running a function. You're providing all of the state up front. And no state is kept. It creates a new essentially creates a new instance of the app in each time you run it. Does that make sense?
Ours doesn't do that.
What's that?
Ours doesn't do that. It uses the same application in memory.
It does, which is a bit of a could be. Well, it's something that you have to be careful about. Is whenever that you're not doing something stateful, right? Like you want to always be mindful of when you're creating a component that you're saving information within that component and not within some type of global scope, for example.
To be clear, you can use the same technique in a headless browser. Both techniques can kind of work. You can be stateful or stateless in both.
I don't know how you would do that in a headless browser.
Which one?
How you would be stateless?
Well, you just kill the browser tab and start it over again.
Yeah, that's what I mean. Yeah.
So that would be stateless.
I mean, it's not state. I don't think killing a browser tab is stateless. That's
why? That would be basically a brand new page request. It would just take the URL as the only. I mean, we say stateless servers if they just take a URL and return a page. Presumably, you have the exact same kind of call to launch a new browser tab, pass it the URL, it does some things, sends back the response. To me, that's just as stateless as.
Well, I guess the comparison would be like a server which runs and handles requests. Those are stateless versus like a CJI, which creates a new instance of the server code for every request. That would be kind of the comparison between the two. So in the case of headless browser, there's like an overhead to like constantly, there's a scaling issue to constantly doing it that way.
Yeah, no, there's definitely a scaling. Like that's the same. I guess to me, the way that I look at it is the same scaling issues exist for both. Like with a virtual DOM, you could relaunch, you have Steele reload every single module again, re-execute every single module, and then take in the request. And that way, you're a little bit less stateful because the actual application couldn't have been storing any prior state, right? Then your application really has to, so that everything comes in, like totally reloads from the beginning every time, but that's slower, right? And you can do it both ways. Same with the headless browser is you could reuse tabs and change the URL and then basically, and whatever, maybe some cookie or whatever session, you change those and then does a new page. Or you can just totally tear down the browser tab every time, launch a new one, and reload everything. To me, it's the same kind of thing. It's just which is virtual DOMs, like you said that what's it called are fast. Headless browsers, they're not as fast as virtual DOMs. Virtual DOMs are much, much faster than like real DOMs, especially to instantiate and create a new document, if you will. And I guess also the difference also is a headless DOM, those are always running in different contexts, where our virtual DOM is not in a.
Right.
That's a big difference too. Yeah.
Yeah. So another disadvantage advantage of using a headless browser versus a virtual DOM is not a real DOM. It doesn't support every API that the real DOM supports. Whereas when you're using a headless browser, you do get that.
Yeah, but you talk about how hard it is to maintain. I guess the way that I look at it is that a headless browser is actually easier to maintain than a virtual DOM because you can probably run your application perfectly in some headless browser. It'll probably.
Right.
Which a virtual DOM, like if you're doing complex stuff with offsets and things like that to be able to render a page. What I mean by offsets, looking at an element's offset, you cannot use a virtual DOM for something like that. Fortunately, for a page response, you're typically not invoking some kind of drag-drop offset calculation measurement.
Yeah, exactly.
Generate your HTML.
Right.
That's the trade-off. Is like if you are doing stuff like that, what's it called will work fine, the headless. But most of the time you're not, so a virtual DOM is so much faster and can run in a single context and not have to share that context. Like it can share one shared context for everything. It's much, much faster.
Yeah, so I mean, when I'm talking about maintenance, what I mean is, from their perspective, it's essentially a fork of WebKit, and anytime WebKit makes a change that potentially breaks their code, they have to pull down WebKit and resolve any conflicts. Just that process can be quite difficult, especially in the case of Phantom. There's no one that actually works on it full time. It's all kind of volunteer work. Which, I mean, I guess the same problem exists for virtual DOMs, but we kind of accept the fact that we're not going to try to support everything. And you get the JavaScript for free, right? In the case of the headless browser, it hosts the JavaScript environment. That's part of the browser, whereas we get JavaScript from Node. So as long as Node stays current on JavaScript, we get that for free. Okay, let's move on. So it's kind of some of the advantages and disadvantages. As you can see, there's some disagreement. Well, not disagreement, but yeah, there's a lot to consider over which approach kind of has the best set of trade-offs. So that's kind of where we've been. I want to talk about like where we stand today and what's next. So kind of the current state of the art, as I said, is virtual DOMs. That's kind of where things have been heading, and we use a virtual DOM in Dun.js for our server-side rendering as well. So here's like a typical page request. You do a GET request for /cart. And you can see this is a response. We have a head, which includes a title. We have some styles that get returned. We have a body which has an app, and this app is going to contain, a lot of HTML. This is essentially, this is the mount point for your application. And then we'll have a script which includes JavaScript, the application itself. And there's potentially more stuff than this, but this is kind of the basis of what you do when you have an application. So the state of the art today, well, let's break this down by each part. You have a title. So this title is usually going to be relevant to a particular page. Like this is the cart page, so our title says cart. So where does this logic live? So you're always going to have something. You're going to have some part of your application which sets the title. So one thing you could do is you could have a separate template. Excuse me, hard to say that. A separate template, which is kind of outside of your single-page application template, and this has the skeleton for your application. You pass it the name of your page when you render that, and then you render the app parts separately. So that's one thing people do. But that's kind of not nice because now you're separating your code, your client code from your server code, which is something that we want to try to get away from. Another issue is that we have link tags, which have our styles. So you're going to have site-wide styles. These are styles that these are your theme for your entire website, and then you're always going to have page-specific styles as well. Like where do those come into play? Like how do people do that? From what I usually see is that people have maybe separate builds that they do to separate out their different styles. In Dun.js, all styles, all JavaScript imports its own styles. So for each component, if you remember the modlet system, with modlets you're going to have a component, it's going to import its own styles. So that way, that's a good way of keeping everything modular. Which is instead of like having some type of build script which builds out different styles from different pages. But even if you do it that way, at some point you have to wire it together so that it knows for this particular page or on the cart page, add the cart styles to that. So you can piece this all together, but we wanted to solve this in a cohesive way in Dun.js. Okay, this is the actual application. This is an app container that your single-page application kind of owns. This is where you're going to do your rendering. Oftentimes, this contains its own router for client side, and usually that's not the same router that runs in Node. There's usually a separate one. This is something that we saw as an issue, is that anytime you create a new route, you have to go to your client side routing file, add the route there, then go on the server and add a route that way as well. So we want to try to get away from having that as a need. Lastly, there's a script which has your application's JavaScript. Ideally, this is only going to be the JavaScript needed to render the particular page. So Steel, if you remember, we talked about Steel's progressive loading. And what Steel can do is it knows that because you're on the cart page, it has created separate bundles for the cart, and it has a bundling algorithm which does shared bundles as well. So Steel is able to kind of know what JavaScript is needed for the particular page. Yeah, so Can SSR, the goal of it is to render all the things. Kind of the current, let's go back to this example. The current state of the art is just to render this part, and everything else frameworks don't do for you. You might be able to piece this together yourself. You likely would be able to do that kind of thing. But Dun.js is a full stack framework, so we want to render the entire thing, render it all.
So let me just make sure I'm understanding what you're trying to communicate.
Huh?
You're trying to say that other, like, of an entire page response, there's things like there's more than just the actual HTML the user sees. There's like the title of the page, there's the styles that the page needs to load, and there's the JavaScript the page needs to load. And most other if you're talking about like React server-side rendering or something like that, they don't really take into account.
Right. Yeah.
Huh?
They only deal with this part, this app. Kind of, you'd have like a mount point, right?
Is that true? They wouldn't. I mean, you could presumably render a React template to a string that included the HTML title or the title element and add a link tag in there and stuff like that.
You could presumably do that, but you can't do that in the client.
Oh, the problem is that the client. Okay, the problem is you're not resharing that template.
Right. Yeah. Exactly.
Okay.
So the ideal is we want to have like one application, very minimal amount of separation of code.
Yeah. So let me try to restate then what you were trying to.
But that's one part of the problem. The other part is like React is not going to know about your CSS or your JavaScript differences. Well.
React itself wouldn't, but someone could put that in.
Yeah, that's what I'm saying. You could wire all this together. In Dun.js, we want to handle this as a framework.
So with React, it's like you'd have to have two templates. You'd have to have like your outer template and then your part that's just for within the body minus the script tag. And that inner template, which is just what's inside the body, that's really what needs to get sent down to the client. But also the title might change, so that also, as you go from page to page, the title needs to change, so you'd have to have some code in the client that deals with that as well. One thing that's interesting that maybe we haven't said yet that I think people should be aware of is that in a server-side rendered single-page application, when the user first navigates to an entire site, that's the only time they're actually going to get a server-side rendered page. As they navigate to every other page, it's actually going to do a push state change, and JavaScript is going to build the update the body, update the title to look as if it went to another page, but in fact, you have there's been no request to the server for that new page, and there's been no additional server-side rendering. So if you think of if on average a user visits 5 sites, only one of 5 of those is going to be server-side rendered. Or 5 pages in your site, only one of 5 of those are going to be server-side rendered.
Yeah, that's true. I think kind of an interesting thing to do is, a lot of people, it's still important. Well, it can be important to do, what's the opposite of progressive enhancement?
Opposites?
Yeah, the opposite of progressive enhancement. It's like
regressive dehancement.
There's a term for it. I can't think of it, but yeah, one thing that you could do just to kind of see if your app is written, I don't want to say correctly, but if you just remove the script so that your JavaScript doesn't run, well, your application could still run as just a traditional server rendered application. So that's something that I found kind of interesting that you're able to do that.
Yeah, our sites could theoretically be made to support no JavaScript.
Right, simply by excluding the script from your template.
Well, no, I'm just saying if people had the no JavaScript flag turned on their browser, Dun.js apps should still work. As long as just everything's URL based.
Right.
The only problem would be form submission.
Mm-hmm.
We don't have that.
We don't have a solution for that. Yeah.
Which we'd have to have some kind of weird post kind of thing set up, but
yeah.
Every normal links and navigating works, just not form submission.
Yeah, you still there?
Yeah.
Oh.
Yeah, still here.
But you cut out. Okay. So yeah, if I didn't get that point across, let me know. But that was really the point of all of this spiel, is that we really want to return everything. And the state of the art today is kind of just doing this much. And the rest of it, yes, you can do, but you're kind of on your own. The framework doesn't have any special guides to do that. All right, so yeah, Can SSR, we want to render all the things. Kind of what were the goals of this project? Well, we want to render more than just the central app container. We want to render everything. We want to include only the CSS and JavaScript needed for a particular page. We want to prevent the flash of unstyled content by inserting styles into the head. What that means that, we go back to this example, if you're on the cart page, we will insert your site-wide styles into the head here, but then we'll also insert like a cart.css styles. And so if the user goes directly to the cart page, let's say you have some special form to like add or remove stuff from your cart, well, you might have some styles specific to that. And they're going to see that immediately. It's going to be correctly styled and everything because we have included the correct styles in the response.
So just to kind of restate what you said there, because of the problem is because we write things as modlets, where you'll have a cart page and it will load just its cart styles. If someone were to go to a server-side rendered cart page, they need that cart styles, although it's loaded by JavaScript down below. If that JavaScript, like if the page is server-side rendered and that JavaScript loads and then that JavaScript loads the styles, those styles will be loaded after they've already seen the HTML. So we need to prevent that by seeing kind of preemptively the styles that the cart page is going to load and move those to the top of inside the head element during server-side rendering.
Yes, exactly. Okay. We want to allow a fully asynchronous rendering without the user having to babysit. What we mean by this is your application will be doing asynchronous stuff in kind of a component-based architecture. You're going to have a component which does request to get data from the server. That's the most often thing to do. But you might do something like you might do a set timeout and only show a particular modal window or something after a certain time. But any type of asynchronous activity you want to be rendered on the server. And traditionally, the only way to do that is you have to, in the way that it works in the current version of Can SSR, in the non-pre-release version, is that you have to tell it, essentially you're telling the request, wait for this to finish before considering the page fully rendered. Does that make sense? Did I say that succinctly or no?
Yeah.
Okay.
Succinctly?
Yeah.
Yeah, not succulently. You said it succinctly, though.
Succinctly, yeah. Sorry, Kentucky. Okay. Yeah. So just to reiterate, applications are in reality asynchronous. Nothing is you don't just have. I mean, and let the way other because they're not asynchronous, because rendering is done synchronously. You have to, inside of Node, you have to do the request separately to get any data that you need to render the app. And then you need to pass that in kind of to the top level render function to have the app fully rendered on the server. And this is different from how you would do it in the client, where in the client, what you really want is you want to have each component doing its own request. So this is a problem that that we've seen a lot of, and this is something that we wanted to solve with Can SSR. So now it's even better in the next version of Can SSR because we just kind of know that all this stuff is happening. And I'll get into how that works here shortly. Okay, so I think this might be a good time for a small demo of what Done.js does. I'll just take a look at, well, should we talk about how to use Can SSR, or is it good enough to show what Can SSR does for you? What do you all think? Should we show a little code?
Are you talking about in terms of the context of the presentation that you're eventually going to give, or?
Well, either one. What do you think?
I would say maybe show like the demo of what the result is, how the network requests are made, how the source is returned.
Okay.
We could break this into a two-parter and showing how to set this up. I feel like that deserves its own.
Yeah, that's true.
If it were me, like I would give I think that the explanation of the problems could be explained a little bit better. And then I think that I would explain the solution, and then I would show how easy it is to set up. Like that diagram in Dun.js's documentation and I put it in the blog article where it kind of like shows, there's the node process and like a request comes in and then part of it's server-side rendered and it's making requests and coming back. Do you know what I'm talking about?
Yeah, I think that's on the features page.
Huh?
I think that's on the features page here, isn't it?
Maybe server-side render. I don't know. It's definitely on the blog article. I might not have got it in here. It's in the blog article. It probably should be added to it somewhere. I would.
Yeah, here it is.
Yeah, that I think does a good job. I think you need to. I think if I totally understand what you're saying, but I think someone else, like who's a user, might not understand. Like with React, and you might need to lay it out for people. With React, like the state of the art is before you do a server-side render, you have some other node code that's really not isomorphic. That's really like custom to the node environment, going and making the same requests, going and making all of the requests for all of the data that page is going to need, and then you pass that big object as the state to be server-side rendered. Right? That's actually very similar to how like if you're writing a Ruby on Rails application or something, right? Your controller sees the incoming URL, makes all of the data requests, packages it up, and sends it off to the template to be rendered. However, that is not how people write client code, because client code, it's nice where you have individual modules able to make their own requests and don't have to do that all centralized one place. So you want to write your code like that, but that introduces a lot of problems, especially when you're running within a single context. Can SSR solves this problem, and with good performance allows kind of like multiplexed responses to happen, where the page we will try to render the page, but we'll see where the page is actually making requests, pause the rendering of that page response, allow others to come in until that response is done, as you can kind of see here in this diagram, and then finish the page rendering and return that to the user. So I think that's a good, like, what I would do is, Matthew, is describe this process a little bit and then just go into like, okay, let's look how easy it is to use with a very simple, like I think the coolest thing would be just to make a very simple, like almost jQuery style app that does a jQuery, like an AJAX request, and be like, let's make the most simple page possible. This is going to say, it's going to be jQuery based, and it's just going to, here's my single page application. If page equals hello, it's going to say hello world, or make an AJAX request for something and then say hello world, and then if not, go to the goodbye cruel world page, and or something like that. Just make AJAX requests. Look it, I wrote it just how you'd write it as a single page application. Boom, it works.
Yeah. So here's an example. This is a jQuery. This doesn't do any asynchronous. Well, it does. Okay. So I'll make this one a little bit better. But this is how Can SSR. This is Can SSR's API. You define some type of state in your application. If you're using Dun.js, you're going to have a central app view model. Now, the app view model acts as the view model for your entire application. This is where like anything that's tied to Can route will be set onto that view model. But if you're doing something like jQuery, you might create your own state. Now, in this case, I'm just returning an empty object, but probably better. Let me write up some pseudo code to do how this should probably work in reality.
Matthew, real quick, does the render function also get past this state, or does it just get the document?
Now it gets the state. Second frame. So it gets the request. The request is going to have a URL. Now, you might say, I don't know, there might be a page where like we do split and pop off the end, and that's the page, so that you have something like, if the URL is something like localhost 8080 cart, then page is going to be cart, and we're going to return the page as our state. Now, so the state looks like page cart, right? Using that information, you could render your application differently. Now, this is a jQuery app. It doesn't really do much. We don't use the page in this example, but we do set the title. So we create a title tag. We append it to the document head. We create an app div, and we append some text, and then we do a set timeout and append some more text. So you could use the page to render different things depending on what the page is, but we don't do that here. So what you get with Can SSR is we provide you a document. Now, for each request, there's going to be a separate document associated with that. So anything that you do in your app, you're going to append to that document that's provided, and not the global document. And as you notice, there's no return statement. There's no, we're not returning any HTML or anything. We're just doing asynchronous stuff, and Can SSR is going to see that we're doing async stuff. It's going to wait for that to finish before it returns the result. Now,
Matthew,
yeah.
one quick question. Document, is that added as a global temporarily while you're kind of within this function, so that jQuery would just, if I did append to and then in quotes I did body, jQuery would try to find document.body itself and work?
No, it does not. That's why I'm doing document head here.
Yeah, but could it do that?
Yeah, probably. My only concern is what we have can wait. So what happens when this function runs? What's the global? The global might be something else, right?
Well, it would always change to.
It would always change it, yeah.
This life cycle's document.
Yeah. So can wait. Can wait is a project. Maybe we should talk about that quickly. Can wait is a project which allows asynchronous stuff to happen. It's the thing that does the waiting on asynchronous activity. So what Justin is asking for is when we actually run this function is if we could internally set the document to be this particular document at each step. We don't currently do that. It definitely is possible. Can wait we probably want to add some hooks into Can wait so that you can set your own globals.
But Can wait explicitly is dealing at least something should be doing that, because if the whole point of Can SSR, so I know Can SSR, maybe Can SSR should be telling Can wait to do.
Yes, that's what I mean.
Yeah, okay, that's fine.
Can wait needs some APIs so that you can set your own stuff. So essentially, these are all separate tasks. From the perspective of Can wait, is that these are all separate tasks. It's going to set timeout each time a task is executed. But it's not going to set any other globals. But yeah, so probably we need some API so that Can SSR can do that. That's a good idea.
My next thing was, so how does this get ported up into a client app?
Yeah, that's a good question. So what you're asking, if this is a client app, what do you do, right?
Yeah.
Well, I mean, that's kind of an open question. So that's one of the things with our server-side rendering is you want to have the same code in the server and the client. That's what done auto render is for. Done auto render handles it handles implementing this API in a way that, from your perspective, you don't have to write any separate code. But there is separate code a little bit that runs differently. Now, if you're just doing a jQuery app, what you could do is you could check if you're running in a browser. So you could say, like, well, just the simple way is just check for type of window is not equal to define. Actually, there is going to be a window.
You wouldn't do that here, though.
Huh?
Well, I don't know what you're going to do, but okay, go ahead.
Okay. Let's say that you have an is browser. What you would do is, if you're running in the browser, you would do...
Would you do this inside create state, I guess is what I assumed you would do this?
Well, create state...
Want to do, like, you know, I imagine I would do this in create state. Like, I would look, hey, if I'm like, I guess I assume create state because I just would think that, like, there's gonna be some bootstrap that always calls create state and then follow it up by render. So I would imagine, okay, well, how do I create the state in the browser versus how do I create the state in the server environment? I'm getting a request object. Well, I might not even get a request object in the client, but I still need the client to produce this state.
So you might do something like this.
Window location or something like that.
You mean like this? You would just call it yourself and then call render with the document, which is going to be the global document in the browser, and then the state object that you created.
Okay. You would do it yourself.
Exactly.
Okay.
So with done auto render, which is part of done.js, it does this for you. So all you have to do is write the template. So you can think of a better way to do this so that we can get rid of this little bit of bootstrapping code. That would be a good thing.
Yeah, because I imagine that would be like the main. It's the same kind of thing where you have like a main module that needs to point at something else.
Well, you could have a different main in the client. This is what a lot of other frameworks tell you to do: is you have a separate main, and then you have that other main which only runs in the client. It doesn't have to check for its browser because it's always in the browser, but it's gonna import this module and create the state and then call the render.
Is I know we're getting in the weeds here, but that's okay. Is create state even necessary as a function? Why is that separated out? Why can't render just create its state?
It could create its state. The reason why we have it create the reason why we have a separate function create state is because Can SSR it wants to know about the state because it modifies the state. It adds information to the state. It does a, how do I explain this? This is how it does its like CSS magic. Is it knows all the pages that you visited, everything that you imported essentially, and it adds that to the state so that when the page is finished rendering, it can render the correct CSS. Does that make sense?
Yes.
Okay, cool.
No.
All right, so let's look at a different example. Let's see. Should we do, what time do we got? We're running out of time. All right, so this is, we talked a little bit about this, but one of Can SSR is that it tracks all of your asynchronous activity, and it uses this project called Can Wait under the hood. This is what Can Wait does: is you provided a function to call. It calls that function any asynchronous stuff that happens within that, like for example, a set timeout, a XHR request. It could be promises. It could be request animation frame. It will wait for all of those things to finish, and it itself returns a promise. And when it finishes, it resolves with like any responses that happen within that. So this is what Can SSR does under the hood. What that means from your perspective is that if you have a model I think we've went over Can Connect a little bit. I think I remember that happening, but if not, Can Connect is our model library. This is a model on the right-hand side here. We're using Can Connect Supermap, which creates our connection, and we're going to connect to the Dun.js chat API, and we're going to provide it a message constructor, a can map, and a can list. This is our simple model. So with the models, there's a get list function. So the get list method calls to the API to get all of the messages. So in our app, we're using this. We're looping over the messages, which are defined in our view model, looping over the value, because messages is itself a promise, and we're just going to display all the different messages. So in our view model, all we have to do is return the promise itself.
So I just, oh, go ahead, sorry.
Yeah, I just wanted to show how this, or show it working. Start my server, and I'm going to do a request. And is this the wrong server? Or no, I have multiple servers running at the same time. Do this again. All right, so as we can see here, this is the response. We have our messages. So we returned a promise for a list of messages, and then we loop over those messages, and those are displayed here. So we have like the name and then the message body. These are not very good messages, but you get the idea. So what Can SSR does is it sees that a promise is returned in your view model. It waits for that promise to resolve before rendering is complete. Additionally, it adds this inline cache. Now, what inline cache is, this is another important feature of Can SSR, is you don't want to, you want any requests that happen on the server to not have to happen in the client. Because you've already rendered the page, you don't want to then do another AJAX request. You know, this is kind of, you know, taxing on your servers to do 2 requests or multiple requests for essentially the same page. So what we do is we include a what we call an inline cache, but what it is, it's just the response data that came back from the client, and we give that a name. Can Connect will use this information to.
It's the response. Just to clarify, it's the response data that came back from the services.
Right, from the get list call. It's the AJAX response. And what Can Connect does is it sees that it already has a cached version of this, so it doesn't do the request the first time. So if you go to this page, it wouldn't do the actual request. Now, if you navigate to another page and then navigate back, when you navigate back, it would do the request. Then this is only for the initial page load. So that's that. Let's show off quickly our CSS as well. So let me see if I have a good example of this. We use our chat application. If you haven't checked out the chat application, if you go to dunjs.com and go to the guide, it walks you through setting up a chat application. Now, the chat application has 2 pages. Let me just show that real quick. It has its home page, and then it also has a messages page. So this messages page has styles specific to it. I believe it does. Yeah, it does. So when this is our messages component, it imports its own styles, which are here. Now, if you're navigating to the home page, you don't want to get these styles, right? You only want to get the styles needed to render the home page. But if you do navigate to the messages page, we want those styles to prevent any flash of unstyled content. All right, so I'm going to start the application. Do a request for the home page. let's pretty this up a little bit. So it's rendered the entire home page, as you can see. Let me go back to that. Homepage has some tabs, it has a button, it has a picture. It's rendered all of that. If you look up top, it has 2 link tags. One is the index.css. This is our application-wide CSS. This is like if you're using Bootstrap, it's going to be Bootstrap. And it also has a home.css, and home.css is just the styles needed for the homepage. Now, my guess is that that's probably the styles for the tabs. That's probably the only thing specific to the homepage. Now, if I go to, I think it's chat, maybe. If I go to chat, we see that it adds index.css and messages.css. So it doesn't have home CSS here, which is pretty cool. Another thing that Can SSR does is, and this might be a bug. Is this wrong? I have to look into this.
Matthew,
yeah.
How does Steele know not to load those modules?
Having not to load what now?
Those styles, those built styles.
Oh, okay. So yeah. So when you get to the client, the styles have already been loaded. So we don't want to reload those. So normally, like when you're on this page and you navigate to another page, Steele is going to fetch the CSS for this page when it renders the page. But if you go directly to this page, we already have the messages style, so you don't want to refetch those because they were already part of the page request. So that's what this asset ID is that when we do server-side rendering, we add this is the module name that gets added, and then we have a CSS plugin.
The asset ID is already there?
Knows that this has already been loaded. So that is that. If we have time to see what any code looks like. Another big thing about what Done.js does, just talk briefly about, we have our routes defined here. Now, we just have a simple route in this app. We have a single page. If we look at place my order, let me see if I still have a copy of that. It has a couple more routes, but our routes are defined here. Just regular CanJS routes. We don't have any routes in the server code. We just have a single. We have a single express middleware which handles all routing. And how you use it is, let's look at the APIs page. Okay. Where is that? Okay, I just link from here maybe. Yeah. So there's a couple ways to use it. If you just want to like render a particular page, you just require Can SSR. You call SSR, and what that's going to do is it's going to create a function that when that function gets called for a particular route, it's going to render that route and return a response object which contains the HTML. But if you're using something like Express, we have a middleware.
Quick question: how does that know? Is that just because it's going to read package.json? How come there's no configuration there?
Yeah, you can pass a configuration object there, which is the same thing that's here. And this is the same configuration. We call this the system object in Steele. So it's just a config object that you use to configure Steele. By default, it will use package.json as your config, but you could provide config object there. So if you're using Express, we have a Express middleware where middleware is it gets in between each request, and this doesn't have the curly braces. But you call the middleware, you call app use with SSR, you provide a config if you want to. By default, it will use the package.json And that's all you have to do. And from then on, all the routes which are defined in CanJS are the routes that are used in the server. You don't have to define separate routes. So I guess that's probably enough. We could probably do a better, more walkthrough in the future where we actually set up an application and do server-side rendering. But I think that's, as far as a walkthrough, that gives you a high-level look at kind of the things that we were trying to solve with Done.js.
Yeah, so to kind of conclude your talk, it seems, I mean, it seems like the premise of it is you're just trying to show the depth of problems that Done.js's server-side rendering solves. So some of them are like performance-based, right? It has really good performance because it's running in a single context, and it's using a virtual DOM, so it's really, really fast. Another one, and then a lot of the other ones are based around maintainability, right? So it's fast, but then maintainable, and the reasons why it's maintainable are because some bigger reasons why it's maintainable are like, well, its virtual DOM looks like jQuery, or like, sorry, it looks like a normal DOM a little bit more than like React does, so you can actually use jQuery to manipulate the page, which is nice, and other DOM utilities, so that you don't have to be like using React or even CanJS really if you want to use Can SSR.
Right.
You have like
SSR will work with jQuery. Can SSR will work with React as well. Yeah.
So you could like potentially have some basic jQuery plugins could potentially even work, like
date time or something.
It'd be interesting to see if jQuery UI tabs could work, because it actually it adds special display nons and stuff like that. That would be an interesting use case, and adds custom class names and things like that. So that's one of the solutions. That's one of the things, is that it uses a lightweight DOM, so that makes it more uses something that looks like a DOM, so it makes it more maintainable. The other one that you kind of talked about is, or you're kind of hinting at, is the problem with knowing when the page response is done. You don't want to have to totally rewrite your code because it's server-side rendered. You want little modules able to make AJAX requests or do asynchronous things. And the new SSR is able to identify which page request is doing asynchronous things, and wait till all of those have completed before essentially rendering the page to a string.
Right.
That's a big advantage. And then it seemed like, and these were the ones that I was probably the least clear on, like understanding the problems associated with it are related to like styles and things like that, right? And it's kind of this weird, once you have progressive loading, it's like once you have progressive loading and you're writing everything as a single page application where every module loads its own styles, but you don't want the flash, that creates a situation where if you just load the production JavaScript at the end of the page, you would see a flash of unstyled content.
Right.
So Can SSR, I don't even know how much of it is Can SSR combined with like Steel and other tools.
It's the integration between those two.
Yeah, the integration between those two removes that flash of unstyled content because it's able to see like what styles would be loading and essentially move them up to the top of the page. And you'll even notice, because CanJS uses custom elements, there was a little bit that you could see that we're even making sure that for IE8, which doesn't support custom elements unless you use like HTML5 shiv, we'll embed that and have conditional comments for just the custom for the custom elements that might be created, that might be embedded in the page. So that kind of stuff,
it's pretty cool.
Is really cool and very tricky that Can SSR gets working for you. Is that a
Yeah. No, it's very helpful. I need to before I give this, this is my first time. I need to kind of break that down. I think the way that you did it was good. It's kind of what are the problems that you're trying to solve? Performance, maintainability. I think probably
And what one was the last
fits
one?
maintainability section.
Yeah.
What's that?
Yeah, it's like
Performance and
there's a
maintainability.
performance thing. There's like essentially in some ways I see your talk as like there's the performance angle and why we do it this way. Why essentially the base technology is the base technology. Single context virtual DOM, right? And the pluses and minuses of that. But you're going for screaming performance when you do that. Okay, fine. So we hit performance. Then how do we make this as maintainable as possible? What are the challenges? And the other one that you mentioned, which I didn't, is the problem with
Routing, part of that.
kind of routing. Well, absolute routing, which I didn't even mention. The other one was that I was thinking is that you want your whole page to be server-side rendered because there's things like the title, and it's not just this main bootstrap part of the body. There's also like how your modules load and stuff like that also have to be taken into account for server-side rendering to when the client is rendering. And I think that that's another way that at least Dun.js' server-side rendering solution, which is just give us your whole template, and we will take care of making the server-side rendering. And the client, once the client reattachment happens, we'll make sure all of those things work perfectly together. There's a lot of trickiness going on in there.
Yeah, the only thing that didn't really touch, the one thing I wanted to, and I don't know the answer to this, is like kind of what's left, like what are we not doing that we could start to do? What are we missing?
Well, I think what we're the next step is, I think our server-side rendering solution is the best by far of anybody who's doing anything close to this. I think the only other thing that I really can think of is the progressive or the streaming responses.
I was thinking that, yeah. When you're talking about, so that's now we're waiting for the rendering to completely finish. Potentially, what we could do is, well, we go through like one loop, right? What do we call that? Like one task. It's not finished rendering, but we can return what we have so far, and then each time a little bit more is finished, we return that part as well. If that makes sense.
Yeah, especially being able to, if nothing else, get out the styles right away would be the biggest thing.
Yeah, that's probably doable. The only problem is like, what if you're only loading a style after you've loaded a particular page? You know what I mean?
But that's how it works right now. You only load certain style of the built styles when you're going to.
That's true. Well, since you're in production, you've already created bundles, so everything's going to be in a bundle. So yeah, that won't be a problem.
And that's where it really matters. But I mean, it's nice. And I guess another nice thing is like the SSR solution works. It kind of understands the difference between what is needed for production and what's needed for development. And being able to kind of toggle between those things. So yeah, I mean, I think we got a good solution, and Matthew's been a huge part of it. And awesome, rocking this out.
Yeah, my apologies for not being more prepared for kind of just started working on the talk.
That's what these are for. These are that you can get prepared, and then you can come back later and explain the shit out of it. Cool, awesome. So thank you again, Matthew. Thanks, Alexis, for joining us. And next week, do you know what we have? You know where we're going to be in our trainings.
Next week we have Can Route, but we may push it back because we have our company meetings.
Our company review, our year-end reviews. So maybe see you next week. If not, see everybody the week after. Thanks again. See ya.